This is section 3.1, Introduction to Determinants. This is another one of those topics that you should have learned originally back in algebra class and then seen it again in multivariable calculus. But let's make sure that we can all do this here. So the thing is the process for finding the determinant is going to change slightly depending on what size of your matrix is. The easiest version is if you have a 2 by 2 matrix. And if you have a 2 by 2 matrix, here's how it's going to work. First off, let me actually just show you that if you see a matrix and it has the normal brackets here, that is considered a matrix. Whereas if you see a matrix with just vertical lines on the side, that is the determinant. All right, it's just slightly different notation for what you want to do. So let's take an example here. Let's take the determinant of A, B, C, D. The rule for that, we're going to cross multiply, and then most importantly, we're going to subtract here. A lot of students forget the subtracting part. So we'd have AD minus BC. And so if I were to take, say, 1, 2, 3, 4 here, take the determinant, that would be 1 times 4 minus 2 times 3, or 4 minus 6 is negative 2. And that works great for 2 by 2 matrices. There's usually no problem taking determinant. However, when we go to larger ones, we're going to have a bigger issue here. So let's suppose that I have a 3 by 3 matrix. And I'm actually going to start with a specific example here. The 1, 2, 3, 4, 5, 6, 7, 8, 9 that we've seen in the past. So here's how the process works. You start in the upper left-hand corner. You write down that number 1. Then you imagine saying, okay, let's remove the entire row that that 1 is in and the entire column that is in. And if you remove those things, you'll see down here you have 4 numbers, and we are then going to write down that 4 by 4 determinant. Then we go to the next number in the row. We're going to have a number 2 here. So I write down 2. Then I remove that row and that column, and then I will have these 4 numbers here, 4, 6, 7, 9. Oh, it's getting pretty messy there. And then we do the third one here, and if you remove those, I know it's hard to see again, you'd have the 4 numbers, 4, 5, 7, 8. So the first thing to remember is that when you're doing this here, there's a name, by the way. This is called cofactor expansion. You don't really need to know that name, but that's what it is. So the first thing to do is remember that you need to include the numbers on the first row, so the 1, 2, 3 there. You then need to have a separate 2 by 2 determinant for each one of those numbers. And the last thing that's very easy to forget is you're going to alternate plus first minus second plus the third to get your final answer. And so this would be 1. Now we do our 2 by 2 rule. 5 times 9 minus 6 times 8. Minus 2. 4 times 9 minus 6 times 7. Plus 3. 4 times 8 minus 5 times 7. And let's see here, that's 45 minus 48 is negative 3. And then that's 36 minus 42 is a negative 6 times negative 2 is going to be plus 12. And then that's 32 minus 35 is negative 3 times 3 is minus 9. And lo and behold, we get determinant 0. And remember from before, if the determinant of a matrix is 0, that means that A is not invertible. So we get information here from this. And this is how it works. You break up based on the first row here. Now there are ways to break it up that are not the first row, but it really doesn't matter that much in my personal opinion, because you can also put these in your calculator, and there's a determinant button in your calculator that can do the same thing in the matrix menu. So to be honest, I don't think it's that important for you to learn every single trick there is here on finding determinants, especially since we're doing this online now. We can kind of do things a little bit nicer, I guess skip a little bit of things here and there. But regardless, you definitely want to be able to take a determinant here. Now, just to show you, what if I asked you to do, say, a 4x4 determinant? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the nightmare you'd have to deal with. You would have 1 here, and then below that you'd have 6, 7, 8, 10, 11, 12, 14, 15, 16. Then you go to 2 here. And next to 2, you'd have 5, 7, 8, 9, 11, 12, 13, 15, 16. Then you'd have 3. And next to 3 would be 5, 6, 8, 9, 10, 12, 13, 14, 16. And then lastly, you'd have 4 here. And let's see here, 5, 6, 7, 9, 10, 11, 13, 14, 15. And don't forget plus, minus, plus, minus. And then here's the great part, is you then get to take each one of these 3x3s and break them up into 3 more 2x2s like in the previous one. And you have to do all of that awful work. Or you type in your calculator and you get the answer 0. For example, if I gave you a 10x10 matrix, you would break it up into 10 9x9 matrices. And then each of those 9x9 matrices, you'd break it down to 9 8x8 matrices. And each of the 8x8s goes down to 8 7x7. And then 7 6x6, and so on, all the way down to, you know, partridge in a pear tree, fun stuff here. So the idea is determinants are not pleasant to calculate by hand. And so what I really want you to do in this class is to be able to do a 3x3 by hand. But even that's a little bit tedious. And the majority of the time that we're going to be doing determinants in this class are going to be 2x2. So even that, I wouldn't worry too much of it. Now, again, if you have something higher than that, feel free to use your calculator, no problem. But the majority of things that we're going to do in this class are the 2x2 determinants, which really aren't bad at all, in my opinion. Okay?